Thank you. Thanks. So, hi everyone. So, we're going to talk about game days, but more specifically about how to test applications. And on the subtitle, I wanted to make it more explicit. I wanted to talk about how to crash test an application. We all know about the crash test for cars, and basically it's exactly the same concept that you can apply for your applications. Because if you think about it, the automotive industry 10 or 15 years ago, they started building those cars, which are complex systems, and it's very difficult for them, once they are produced, to know if they are secure or not. So what do? They just crash them, and they see how they react, right? And unfortunately, this is not something we have in the IT industry, but perhaps now, if everyone watching this talk is pleased by the idea, perhaps this is something that we're going to do more further. So before going to those details, I wanted to do a quick update on Amazon. I think everyone knows Amazon.com, the retail website, and in fact, Amazon is broader than that. What we build is platforms, because the core idea of Amazon is to build systems that you can reuse to build your own business, right? So this is something that we've been started doing with the e-commerce platform, where everyone can sell their own products on top of the Amazon logistics platform. We did the same also for books. Anyone can be a writer, an author, and you keep 70% of your royalties. Your book can be published directly on Kindle. And on Amazon Web Services, the cloud computing platform, this is exactly the same. So technically today, we launched our version of the Russian website on aws.amazon.com/ru. You can also follow us on the AWS Oblako Twitter handle. And basically, Amazon Web Services is a set of infrastructure components. There's more than 36 different services now. They range from S3, which is very well known. Amazon S3 used by Dropbox. For example, if you put a file on Dropbox today, technically you're storing the files on S3. Amazon EC2, already well known, and it ranges up to services like Redshift for data analysis, Kinesis for real-time data streaming, and so on. So the idea is those are building blocks that allow you to build a system, and I've been gifted over the course of the last years to meet many of our customers, like for example, Spotify, Coursera, who are here as well. And many people are talking about this, right? So when you build an architecture and when you're building operations, you're talking about scalability, durability, and so on. But in fact, when you dig deeper, what people want is resilience, right? Everything we saw before is a consequence of resilience. So there's a more simple definition of resilience. I like it much. Is the capacity to anticipate disruptions and to adapt to events and continue to deliver value. And if you simplify it again more, resilience is the ability to cope with change. So you can think about resilience as the ability to adapt, like living organisms that can evolve and so on. And if you take this definition of resilience, here the keyword is adaptability, right? And adaptability, this is something that many people using Amazon Web Services experience with services like auto-scaling. I think it's pretty well known. Auto-scaling allows you, for example, to add and remove Amazon EC2 instances depending on the load, and then on front you have a load balancer that is going to be able to absorb and redirect the traffic to all those instances. But this is programmated adaptability, right? Real adaptability requires humans. And in fact, if you think about it, you cannot have a resilient architecture if you don't have the humans that are operating this system comprised on the system. So the mistake that I saw that I did myself many times, is to think about an architecture, think about an IT system, only thinking about the IT components or the infrastructure itself, completely forgetting about the human factor and the people who were operating this system. But in fact, you have to look at the whole picture. That is, a system is completely useless without the team that is operating it. And the point here is, if you look at the best systems that exist, probably Yandex, if you look Netflix, if you look at Coursera, if you look at many other companies, they have probably the best architectures, but also because they have the best operating team, right? So it's not one or the other. It's a conjunction of both. So the next question is obviously how you can have the best operations, right? And this is by training and by playing them in a dedicated environment. Because if you want to make a good living organism, you have to train it, right? This is not something, you cannot build it from the ground up. So the point here is to play in a simulated environment is not a new idea. This is a picture of an old Boeing simulator, because at the beginning those airplanes were so complex to drive that you needed to try first before making it safe. So now, for example, this is a more modern version of an Airbus simulator. And those two guys, they seem really happy, like, yay, but they just crashed the airplane. But it's okay, because it's a simulator. It's okay. So the same in medicine, right? So I don't know if the doctor here just killed the baby, but the point here is that you have this safe environment where you can try things, right? And it's not only to try things and to learn, right? But it's also to simulate crisis situation, very difficult situations you cannot, or you sometimes don't have in real life, or you don't experience often. Because there's a nice saying that puts it quite nicely. It's good weather doesn't make good sailors, right? And often when I interview candidates for either development team or operation teams, I ask them what are the biggest failures or the biggest disruptions they had to go through. And if there were none, probably they didn't learn a lot. Because think about yourself. That is, what are the moments in your life, in your career, where you learned the most? Chances are it's probably during like a service disruption in your company and these kind of situations, these kind of very tricky, difficult situations. So you want to reproduce here these kind of situations, but in a safe environment, because you don't want to disrupt the business, right? So when you do game days, first step is obviously like everything, you have to prepare that, how you run the game day first. So setting the stage, you have two teams. The supervisors, the ones that are going to run the game day, and the ones that are going to operate and audit the players, and the players, the ones who are going to be in the simulated environment, right? It's like a role play. So then you have to clearly understand what do you want to test, because usually perhaps it's too difficult to test the whole thing, to test the whole system, right? So you may want to test only some parts of the system and see how you can test it. So a very good technique here, it's the pre-mortem technique. So a lot of people know the post-mortem. That is, once you have a failure and once the failure is fixed, you want to go back on track and try to analyze the timeline and see what happened. Here you want to do exactly the reverse. So the idea is pretty simple. It's like a brainstorming situation. You want to take your engineers and just think about, hey, what are the different ways the system could fail, right? Because if you do it without applying this kind of technique, and if you directly go to your engineers and you ask them, hey, how the system can fail? People sometimes tell you, hey, I mean, come on, the system, I designed it myself, it cannot fail, right? So here the point is you gather everyone and you're in a room and let's imagine the different ways our system can fail, right? And it will give you nice tips of things to test during the game day. So then you have to create the simulation environment. Obviously, you don't want to do that in production, right? So this is where Amazon Web Services is very helpful, because as you perhaps already know, Amazon Web Services gives you on-demand capacity that is elastic, and you only pay for what you consume, right? You can rent virtual machines or storage for a couple of hours. So it's nice to use AWS for your tests. But the point that is the most interesting is that there's an API for AWS for everything. Everything you can do on the console, on the mobile client, and so on has an API. So you can basically program your steps. And basically, AWS is a kind of a programmable data center. So here we have a service called CloudFormation, which is a stack-based provisioning service. It's to bootstrap an architecture from the greenfield, from nothing. So the idea is pretty simple. It's like this. So you have a CloudFormation file, which is a simple text file, a JSON file, that you give to the service, you upload it, and it creates, for example, this architecture, right? So it completely recreates an environment from scratch, from nothing. We had a lot of customers that are starting to use it, for example, for disaster recovery, on-demand disaster recovery environments. If you can recreate a complete system just from a description file, it can be good also for disaster recovery, right? So this is an example of a CloudFormation snippet. As you can see, there's nothing magic here. It's just a JSON file. So this is a segment that, for example, allows you to create a relational database with Amazon RDS, a MySQL database. This is another example to initialize an EC2 instance with basically whatever you want here. Here, for example, I deployed a couple of packages with yum. Under the brackets here, you could put the version, or you can, for example, deploy here a zip file. You can deploy also a Git file. You can have a chef recipe, whatever, right? But the point is here is you have a text file. And because you have a text file, the developers here will definitely understand that you can version it, right? So one of the best practices is to put the CloudFormation file along with your source code, because now you will have the source code with your architecture description file. So when you want to go back in like older versions, you will have the architecture that support also the older versions of your code. So the way to do it, I took a couple of screenshots because I didn't have time to do a demo here, but you go to the console, you go on CloudFormation, you create a new stack. Here you give it a name, you upload the file. The file can have parameters. For example, the number of front-end web servers you're going to have, the size of your database in terms of storage and in terms of instances, the keys, the logins, and so on. You can simulate the cost once you uploaded your template. So here, for example, you see that this very small architecture with 4 nodes will cost me $72 per month. And then, well, you just click Create. You're going to see the log of all the events, all the different steps that are taken by the system to create your complete architecture. So you can have synchronization points, you can have rollbacks, you can call other CloudFormation scripts, so you can have nested procedures and so on. And once it's created, well, you receive also those notification emails, and you have all the resources that are in the environment. Obviously, they are on AWS. You have access to it completely naturally, like any other resource you can create yourself. And you have here, it's the main endpoint. So the entry point that I deployed here was a simple blog site. And once you finish your test, once you finish your game day, one of the nice features is that CloudFormation can completely roll back a stack and destroy everything that has been created, right? So you're back from a clean state. One of the things as well is if you're running already with Amazon Web Services, is I recommend you to create another account. So you have a completely separated account for your game day. So you have a different billing, and the billing cost and the networking cost will not impact your main bill. So the second point is to simulate activity. So this is a tricky one, and it's pretty interesting how you can say it is. My preferred technique is to replay pre-recorded network activity, right? I remember when we were working with Instagram, at some point, Justin Bieber created an Instagram account, and well, obviously they pre-warmed the system and so on, but it would be nice to like have the pre-recording networking flow of that specific moment. Then you have like this kind of a tape idea. Let's replay what happened during that time for the simulation environment, right? So, I mean, there's many ways to do it. You can do it with a TCP dump and collect all the TCP traffic and then replay it. There's Ruby projects like VCR who allow you to collect everything that you do at the HTTP level. And this is interesting because this is a quote from the CTO of Etsy. The production environment is the only place where you can validate your code. So don't get me wrong, I'm not telling you don't test your code, test it in production. I'm telling you that you validate your code in production. Why? Because the production environment is the only one who has real users, right? I mean, it seems completely silly to say it like this, but when you test your code in the test environment, you don't have real users. And you know that real users sometimes do things that are completely awkward with your application, right? That's why you want to validate your code in a production environment, and replaying traffic that comes from the production environment is the best thing you can have for your application. Otherwise, you can obviously do load testing. So load testing doesn't look like a real traffic, but it will allow you to stress test the components of your application. So you want to do this kind of a throttled load testing because you want to control how much load you're going to push. And for that, I will recommend you to use EC2 spot instances. So the main difference is on the pricing model. Here you have the cost for the on-demand EC2 instances. You see, for example, here, an M3 medium is $0.077 dollars per hour. But if you look at the spot market, this same one is 7 times cheaper. So obviously, you don't have any guarantee whatsoever if you're going to have the instance or if it's going to stay during the whole test. But when you do a load test, typically you're going to start perhaps tens or hundreds of those instances. So losing a couple is not a problem during a load test situation. And as you can see, the costs are really down compared to the on-demand market. So a couple of tools to do load testing. Well, actually, there's many, many, many tools. Those are the 5 ones that I use myself that work pretty well, except perhaps Apache JMeter, which is a bit tricky to use it at a very large scale because you need RMI synchronization points. The other ones, I mean, Locust.io is really good because it's really built from the beginning to be distributed, and it provides you a nice UI to control the loaders. But actually, I think mostly every engineer who had to do load test tried first to build his own load testing framework. So there's many good things out there, but I would recommend you to start with those. And in fact, one of our customers, Activision, also used those techniques and those tools to test one of their games, which was Call of Duty. So it's a massively multiplayer game. And here, when you are developing a game, you have an SLA sometimes that tells you that your backend should respond under 70 milliseconds, right? So when you introduce code in the backend, how do you know that you're going to be under the 70 milliseconds response time, right? Well, actually, you don't know. So that's why you want to test that, right? And this is exactly the same things you are going to do during a game day, during a simulation time. So once everything is ready, you set a deadline, and then you will see everyone in the team trying to prepare and polish the system just before the game day. And one of the key points is to make it fun, right? So I really emphasize on this because put yourself in the shoes of the guys who are going to play in the simulated environment. They know that something awkward and something really bad is going to happen, and they are going to have to fix it, right? So it should be fun. That's why we don't call it a crash test day. We call it game day, just to emphasize the fun part of it. Because, I mean, no one wants to be put in a difficult situation. So, I mean, just emphasize that it's for playing, right? And because when you did dramatize it, that's when you maximize the learning opportunity, right? So make it fun. Have some beers once it's finished, and so on, and then play. So this is when you're going to simulate the failures, right? Like, for example, when you are in an airplane simulation, this is part of the course where you're going to be a pilot of the Airbus line. They're going to simulate different things. For example, an engine fails. They are going to simulate also all the wings are down and so on. So they're going to simulate many things. So you do exactly the same thing for your environment. Oh, yeah, quick reminder. Life is harsh, right? Life is really, really harsh, but in very clever ways. So, for example, in life, you will see that the day you're going to have a service disruption because your NAS is out of capacity or whatever, this is the same day where the main engineer is sick at home because the day before you threw a party and you have an absolute headache and no one is here to help you, right? So you're going to have all those combinations of things that make a service disruption situation very difficult. That's why you're never going to be very sadistic compared to what life can do in real situations. So, a couple of techniques. The obvious one, I mean, you're running on AWS, you connect to the console, you shut down the load balancers, or you shut down the application servers, you destroy a couple of nodes, a couple of EBS volumes, virtual hard drives, and so on, and just let's see what happens, right? So, I mean, there's many different ways to do it. So terminate is obviously the harsh one. You can modify security groups, which is the equivalent of firewalls or subnetworking. So you can, for example, cut subnetworking sections of your application. It goes down to, I like this one, putting garbage on the etc host file, which is pretty nice to simulate, for example, repositories or DNS resolutions that you don't find and so on. Another one is using Chaos Monkey. So Chaos Monkey is a framework that has been developed by Netflix when they're running AWS. Basically, in a nutshell, it's a framework that is going to connect to the AWS console and randomly terminate instances. So the thing here is that Netflix is notoriously known to run this system in production. And if you think about it, it's a live video streaming company, right? So in production, they have a system that is going to randomly choose a server and terminate it, right? So, well, if you don't do it in production, you can definitely use it on a game day. The key point here is once you're going to simulate those failures, you have to timestamp them. You have to really write down at 10 a.m. I terminated the database, because then when you're going to do the debrief, you want to have a precise timeline of all the events. But we're going to get back to this later. The point here is you really want to record everything that's happening, not only in the system, but what are the actions that the people took. The people who are in the simulation environment, what did they do? How did they react when they noticed the failure and so on? For that, we have another service which is free, which is AWS CloudTrail, which allows you to record everything that happens at the API level of Amazon Web Services. So basically, you have those JSON log files that are extremely complete, and that tell you what are the different users' actions, what did they do, they connected to the EC2 console, they created new machines, and so on. So everything is time-stamped, and then you can reproduce on the timeline what are the actions that the people in the playing environment did. And the third part is the debrief. So this is when the important things happen. This is when you have all the learning that happens. Because for example, when I told you about that you have to keep the logs of everything, all the actions that you do, it allows you to answer this key question. For example, how long does it take the team to detect an event and to take action? Because keep in mind that if during a game day, if during a simulation environment, it takes your team 5 minutes to detect that a database is down, in real life, it will take them 2 hours because they are not paying attention, right? During a game day situation, they are paying attention. They expect things to fail, right? So another important learning is the communication channels. So this is part of the collection of procedures that you can have to tell your teams how to react in a crisis situation. How you communicate between the different team members. Do you have shared file systems where people will annotate the actions they take and so on? Because sometimes service disruptions can span not only across hours but across days. So you have to keep all this up to date. You have to keep your different teams, perhaps in different countries or in different territories, also in sync. So this is also something important to know before, because I saw many teams that, for example, they had a service disruption and well, they didn't have those tools in place, so they quickly tried to communicate via WhatsApp, via SMS, via whatever tool. So this is something that you should have beforehand. Also with the chain of command. So during many simulations, one of the things I noticed is that a lot of time was lost because there was no clear commander and no clear decision maker. So people tried different things to restore the system, but because no one was overseeing the restore operations, many times a lot of time was lost in discussions and in debates on what would be the next step and what people should do. Oh, another variant is an interesting one is what some people call the rookie day. So when you have new hires in the team, well, they have to go through the game day, right? So like a couple of weeks or a couple of months after they join the company, you do a special event for all those guys. and it's going to be the best training that you can provide to them. Also, with the reverse way is the starless day. So in all the teams, we have those rock stars engineers who know the system completely inside out. They have in their mind the map of the system and so on. So do a game day without those guys, right? Because you often tell this story. Well, if a bus hits this guy, we're in big trouble and so on. Well, test it, right? Let's see what happens. And it's also a good learning opportunity for the other guys. So the main point to do the game days for me to conclude is, first, validate your assumptions. So this is a really strong one, because I saw many architectures and many systems. People told me, yeah, it's completely scalable, it's reliable, no problem. The latest one I saw, it was pretty nasty. The front-end web servers were on an auto-scaling group, so they were able to create and reduce load depending on, reduce instances depending on the load. But the problem is that the front-end instances were served by a chef master, by a chef repository. And the team didn't have the right metrics to understand that the master repository was down. So yeah, the system was creating new instances to sustain the load, but those new instances didn't receive the configuration, and they didn't receive the recipe to deploy. So even if on paper the system was scalable, on practice it wasn't, definitely at all. So even if you think your architecture is extremely reliable, durable, and whatever you want, a system is reliable only when you prove it. So you have to really validate your assumptions, prove your architecture, and also know your procedures. Because even if you have the procedures to restore the system, if no one knows where to find them and how to apply them, it's completely useless, right? So the best way to understand if people can apply the procedures is to really simulate that, is to do a game day. So just to close this, keep in mind that the best learning opportunities you can have is from failures. So we are all happy to be successful, because at the end, I mean, we are paid to be successful, right? When you choose a lawyer, when you choose a consultant, you choose the guys who are the most successful. You don't choose a lawyer or a consultant because the guy failed many times, right? So we like success, but success doesn't tell us much about what we do. A failure tells us a lot, right? So keep this in mind. Success makes people good, but failures can make people way better. And again, my last point, this is good for sailors, but it's also good for operation people. So good weather doesn't make good sailors. With that, if you do game days, let me know. Thank you for your attention.
Thank you, Carlos. It was very interesting talk.
Thank you.
It was almost about what we do in Yandex. So it's a pretty common technique. Коллеги, вы можете задавать вопросы. Не забывайте, что можно писать в Twitter, те, кто слушает нас через интернет.
There's a question here, apparently.
Thanks. May I begin? I'm here.
Where are you?
Thanks for your speech. Your sentences is very inspiring. So my question is, how do your developers react? Do they panic, or are they completely calm? And how do trainability of your developers to not to panic and
it's
repair system?
I think the question is about how the developers react, because I talk a lot about ops, but well, now we all know that we want to talk more about DevOps, so the developer and the operation people. Actually, the developers are sometimes the one that learn the most, because most of the operation people, I'm talking about people who have perhaps more than 5 years of experience, they already went through a real situation of a service disruption. Developers, not that often, right? And developers sometimes, when they do game days, they start to realize that for example, oh, the code doesn't react at all when the database is not available, right? So they start doing fancy things, like, for example, okay, what happens with the code when the database is not there? So you can write into a cache, you can write into a queue, you can have all those different ways, and it creates a really good feedback between the operation and the developer team, because now they start to understand what the operation guys go through when there's this kind of situation. So the first one is to also start thinking about how your code can be adapted to these kind of difficult situations where components that seem critical are not there, like the database. And the second one is it often teaches the developers to put logs and to put debug actions that allow operation people to understand how they can manipulate the code. But the last part of your question, how not to freak out, that's the whole point of a game day. So that's what I say when you have to call it game, so people don't freak out. And if you do it quarterly, so if you do that, or even sometimes some teams do it every month, that's when you stop freaking out, because you've been doing that a couple of times, and you know that things are going to fail. You know that you cannot have a 100% bulletproof system. So when you do it many times, you start to understand that it's part of life, and you're constantly evolving your system to make it stronger. Thanks.
You know, Carlos,
Thanks.
I have another thing that works very well with the situations. When your developer sits near your administrators,
yeah.
and when things goes bad, when developers listen what administrators say about the product,
Yeah.
usually after that problems, developers try to make a better,
Yes.
make their code better. So when you're trying to make your game days, you should involve your developers in this process.
Oh yeah, definitely, definitely. They should be part of the simulation time, because they should see themselves how their code fails.
Yeah, and
Yeah, why not? Why not?
And they
For the
should be
debrief,
happy.
you can, I'm sorry, just one point was also why not involving everyone in the team? The thing is, involving marketing and product guys can be difficult in terms of agenda and so on, but let's have them participate to the debrief. That's interesting, because you do it a game day and you do that Friday afternoon, the debrief, people come, discuss, have beers and so on, and at the end, the CTO, the marketing and so on, they understand what are the limits of the system and when it can break and how you can make it break.
Hello, thank you for a wonderful presentation. One more question about developers. Actually, does it make sense to perform such stress tests for developers team? And if it does, could you please share some methods to test developers as you provided for operation guys?
Yeah.
Thank you.
So, so for the developers, what's important is to sometimes test sub-components. So people are talking a lot about microservices now, so sometimes you want to test in isolation some parts of the system, but not only do stress tests, because the stress test or load tests will give you a good indication of the break-even point. It's exactly like in physics. You have a metal piece, and you want to understand when this metal is going to break. So for your code, it's going to be exactly the same. Given a specific instance size, how many incoming requests your server or your service is able to maintain, is able to sustain. So it tells you also good information about the price that you can have, that you can sustain. Now, the trickier part for the developers is to be able to replay the test exactly the same way multiple times. Because when you find a mistake, you want to be able to debug and to go back and fix that. For example, there's, I don't remember the name, but I'll sing back to you after the session. If you record TCP dumps and you replay TCP dumps, some caveat is that you're going to replay also the HTTP cookies. right? So your code sometimes is going to do fancy stuff because it's going to see the same cookies and the same HTTP sessions replayed again and again. So there's different techniques that you can use, and for that, Gmeter is perhaps the best one because it not only allows you to replay only HTTP traffic, it can replay also database connections, RMI requests, and so on. So the whole point for developers is to be able to record traffic and replay it, right? So it gives you a higher level test than what you can do with mock objects or unit tests, because here you're going to test the system with the database and with the other components.
You know, Carlos, that was a question from Twitter. You said that you need to test something in production, but do you use some kind of pre-production or staging?
Okay, yeah, no, it's important to, every time I pull this slide, I'm fearing that people will misinterpret it. You should not test in production. You should test in your pre-production environment or your test environment. Production will help you to validate your system. Validate because even if functionally it works, perhaps in a production environment, you're going to see some side effects that you couldn't simulate because you didn't thought people will use your application like this. The classic example is search engines. Right? And that's how people 10 years ago started to experiment with JavaScript or SQL injection attacks, because no one thought that someone will enter SQL code on the text field, right? I mean, that's crazy, right? But people do it. And these are things that you only see in production. So you test your code in a test environment, but you validate it in production. And I think there was a couple of sessions today about A/B testing. And now in mobile applications and also in web applications, you can have this concept of enabling or disabling dynamically segments of code, flipping switches that can be even in a DNS repository or in a static configuration file. So your code you push code into production, but you enable it dynamically. So that's one of the good ways to validate your code, and if it doesn't work correctly, fall back to the default version.
And what could you say about Chaos Monkey in production environment?
Yeah, so no, it's an interesting one because Chaos Monkey has been designed first by Netflix to make sure that the auto-scaling groups are set up correctly. So for those who are not using Amazon Web Services, auto-scaling groups is a system that allows you to define how you create and destroy instances. For example, you can say, if the CPU load of my web servers goes above, let's say, 80% during 5 minutes, then I'm going to add 2 more servers. And conversely, if the CPU load goes below 10% during 15 minutes, then I'm going to remove 2 servers. So it dynamically adjusts the load. The thing is, it's easy to make configuration mistakes. And every time there's something that a human can configure, you want to test if it's done correctly. So the idea was to say, hey, I mean, let's run this system that is going to kill instances and see if auto-scaling is going to detect that and replace it with another machine.
Any other questions from our listeners? Нет? Ни у кого больше нет вопросов?
Okay. I'll be around, and you have my Twitter handle. So if you have any question, please don't hesitate. Thank you.